how we at Mercedes-Benz Tech Innovation rocked our migration of around 420 Apigee Edge Microgateways to only 3 Kong instances with 0 downtime. Our agenda for today looks like this. Before we dive deeper into our main topic, let us tell you more about the API management platform of Mercedes-Benz called OneAPI. Next, I will tell you about our Gateway as a Service platform powered by Kong, and Benny will show you how we have done the migration from Apigee Edge Microgateways to Kong. But first, let's start with some information about us.
Yeah, so my name is Benny. I've been with Mercedes-Benz Tech Innovation for over 6 years now, and I've worked for various data gateway products over the years, starting with some SOAP-based custom developed gateway up to now, basically the API gateways based on Kong.
Hi, my name is Dominik, and I'm a senior technical lead at Mercedes-Benz Tech Innovation. That means that I'm leading our DevOps team, and if there's some time left, I'm also developing our platform. Mercedes-Benz Tech Innovation is a subsidiary of the Mercedes-Benz Group. As you know, Mercedes-Benz manufactures luxury cars. However, without Mercedes-Benz Tech Innovation as an integral part by providing IT solutions, putting those luxury cars on the streets would hardly be possible. We are delivering luxury IT solutions. For example, our Gateway as a Service platform, so our business partners can focus on what's most important to them. Mercedes-Benz Tech Innovation has been founded in 1998, and it has been constantly growing both in revenue as well as in employees. Today, there are 4 locations in Germany and a project hub in Kuala Lumpur. We have around 1,250 employees and had a revenue of around $200 million in 2021.
Yeah, so if you drive a Mercedes, like this beautiful EQS here, then maybe you already are familiar with this interface, which is our car configurator. Now, this configurator UI actually uses a lot of APIs. So there's obviously the vehicle configurator API, which allows you to basically select colors and the rims and hundreds of options how you want to configure your car. And then the result of this is also sent to the vehicle image API, which basically renders a picture of what your car will look like. And not just from the outside, but also from the inside, various angles. And you can actually get to kind of experience your next car already there. In addition to that, there's more APIs used on this page, like the dealer locator and your account data API, and so on. All of those APIs are managed by our API management platform called OneAPI. So this is basically a central platform for API management used within the whole company. Currently, it's used to document about 1,500 APIs. And there's 2 main entry points. So we've got the provider portal, which can be used by anybody wanting to provide an API to others. There you basically document all about your API, and you can manage everything. You can get analytics data. And then there's the consumer side. So if you want to consume APIs, you can use that portal to search for APIs. You can subscribe. You can get the documentation. So yeah, so this is basically the core of the platform here. Then again, it's not only used to document your APIs, but also to manage your APIs. So it's a central API management system. There's multiple gateways connecting to it, and those gateways are distributed all over the company. And basically anybody can host such a gateway, and they can connect it to the central platform. And the gateway will then retrieve data about your API, about access controls, traffic quota, about what metrics it should send to the backend. All of this is enforced by the gateways. How that's going to work, that's what Dominik will explain now.
The gateway integration until 2020 looked like this. Every API provider could host their own microgateway. So instead of a central gateway, we had hundreds of federated gateways. The success factors were that the API providers had full control over the operation and deployment. However, we've also learned that the configuration is bound to the API management, and we needed to adapt new deployment models. Additionally, not all teams were DevOps ready, and local managed gateway stacks had evolved. Therefore, a new gateway integration model had to be developed. Now it looks like this. These are the main benefits. Now there's a standardized gateway integration API allowing integration of different gateway types. Mercedes-Benz decided to focus on Kong as their recommended choice because it's suitable for both small and large instances, providing simple configuration, operation, and monitoring. Within 2 months, we had our proof of concept ready and were able to roll out our first production version a few months later. In order to connect Kong to our gateway integration API, we developed a plugin, and we call this the One API plugin, which integrates a lot of functionality within a single plugin. It connects the Kong gateway to the API management platform and automatically enables authentication and authorization based on our platform subscription model. Additionally, we implemented some other highly requested features like upstream basic auth. Furthermore, the plugin has a multi-level cache to improve performance and is therefore also very resilient against connectivity issues. While we want to follow the federated gateway approach, some business partners just don't want to host their own gateways. In the past, we implemented a gateway as a service based on Apigee Edge Microgateways.
Yeah, so this is what the old service looked like. We basically had a Kubernetes cluster, and it was running hundreds of micro gateways, which were configured via config files that we could check into the Git repository. And then basically a Jenkins job would run that would then deploy and undeploy those gateways, basically spinning them up and down depending on the need. Now, for security reasons, not everyone in the company had access to that Git repository. So any config changes that our consumers wanted to do to their gateway instance, they had to send us the config via email. And then we would basically check it into the Git repository so that Jenkins could run, and we would watch out for conflicts and everything. And yeah, it was a little messy and a little complicated. And basically with Kong coming up, we said, okay, we want to switch to Kong and we want to switch to a new plugin and we want to simplify the setup. So the main idea was to basically replace all those micro gateways with just one large Kong instance. But keeping the rest of the stack and the process around it, that's just not desirable. So that's not something we wanted to do. We wanted to go with self-service. Also, a data center move was basically impeding. So yeah, we had to plan for that as well. And so we said, okay, we need a big migration plan. We need to set it up new. Now, not everything about that was easy, and we'll get there in a minute. But first, Dominik will show you what our stack then basically looked like.
Let me introduce you to Mercedes-Benz Tech Innovation's Gorilla service. You might ask yourself why it's named like that. Well, if we take a look at the Kong logo, it might be more obvious. Gorilla Service is a self-service platform for managing and setting up Kong API gateways in a simple and concise way. Building our new gateway as a service platform, we have always been asking these simple questions. Why, how, and what? Oh, let's start with why. Why are we creating this service at all? So this question was and is still at the center of creating and improving our product. The purpose of our Gorilla service is to make Kong and our Kong One API plugin easily accessible and consumable for tech-savvy and non-technical people at Mercedes-Benz. Also, some people just want managed services, like me. So in a nutshell, we want to enable our business partners to focus what's most important to them. Next, we need to keep in mind, how can we achieve this? There's a simple answer to this question. Simplification. That is, by reducing advanced settings to their bare minimum and providing live input validation and sanity checks. In other words, we are providing a simple-to-use graphical user interface. Last but not least, what do we provide to our business partners? We built the Gorilla service to be a self-service platform for managing and setting up Kong API gateways in a simple and concise way. Our users don't have to worry about all the configuration possibilities, clusters, scalability, updates, backups, and so on. Here's what it looks like. As you can see, we have hidden advanced parameters for novice users and pre-filled those fields with suitable default values. With just a few clicks, you are able to get your own services running and make your API accessible for others without the need to think about clusters, deployments, monitoring, logging, and so on. So you might ask yourselves, what did we have to change with Kong to achieve this? This will give you a rough idea what our architecture looks like and which technologies we are using. We are simply wrapping our Gorilla service around a vanilla Kong and didn't change a thing. However, we included our OneAPI plugin with Kong in order to talk to our API management platform. Our graphical user interface is built with Vue.js and Vuetify and simplifies the setup and configuration of Kong and our plugin. We also have our own API between our graphical user interface and Kong, which provides input validation, user management, and authorization. This API is written in Go, since most of our team members are proficient in Go. The Kong gateways are bundled with our OneAPI plugin and use a Postgres database for the configuration data. Our OneAPI plugin uses Redis as a cache for the API management data. All of that and some more is running inside a Kubernetes cluster. Currently, we are serving a very happy customer base. However, we plan to expand our platform to be even more convenient by integrating more features and making it possible to bring your own domain. We also want to provide more features like high availability by spanning Kong across multiple regions and using Kong in hybrid mode. A great product needs great people. So, last but not least, here's a photo of our passionate team at Mercedes-Benz Tech Innovation. That's it from me. Benny will now take over and tell you more about our migration.
All right, so you might remember this slide. That's where we came from. And from there, we basically wanted to go to something like this. And as promised in the title, we actually did this migration without any downtime. But of course, with such a large migration, you always run into issues. So, and I firmly believe that talking about the challenges somebody runs into with such a project is the greatest learning opportunity. So yeah, feel free to take something from this presentation and learn from it, or at least have a good laugh about what we ran into. What follows are just simplified diagrams, of course, but if you have any further questions, you can just ask us in the Q&A later. So this is basically step one. This shows how the API traffic was routed. So think hundreds of those micro gateways here instead of just the two, but obviously we want to keep it simple. Each API that an API provider wants to expose basically had their own micro gateway running. And each micro gateway has its own ingress configuration in Kubernetes. So basically this was done via the path, and basically with a path prefix, Kubernetes decided where to route the traffic to which gateway basically routed. And so in this first step, in the compiled phase, as we called it, we just installed Kong in parallel. And Kong was installed with an ingress that basically is like a catch-all. So anything that did not match any of the other ingress objects was routed to Kong. Then what we did is that we set up our routes on the Kong side based on the configurations that we had in the microgateways. So we basically had a path filter that matched what we had in the ingress before. And we also added an additional route with a prefix that was just like /Kong _ and then the basic path. This allowed testing in parallel already. So with the microgateway still running and serving the traffic, a consumer could also prefix the path with Kong _ and the same traffic would be routed via Kong to the same target already. And they could start testing. And they could see, okay, does it work? Does it fulfill my needs? And the next step was then to start moving actual live traffic over to Kong. And we did that by removing ingresses individually. We kept the microgateways running, but they didn't receive any traffic anymore. But instead, a call to /first API would now be routed to Kong automatically. And this gave us the option that we had an easy fallback. So if anything doesn't work, we could just install the ingress again, and the traffic would be routed back to the microgateway. So we did that for the other microgateways too, slowly increasing the traffic that was routed via Kong. And in the end, basically everything was routed via the compilot. And yeah, everybody was happy. But of course, we ran into issues. And it's good basically to go via phases. So with this first phase, we could already run into some issues. So it's always good to fail fast and to see, okay, where might issues occur instead of migrating and then running into issues. So yeah, the first issue we saw is that Kong was configured to be more strict about the target TLS settings. So all the targets that we basically routed to, well, most of them are using HTTPS, and some of them didn't have proper certificates. Some didn't have any validly signed certificates at all. And some had a valid certificate, but it used a different host name than the one that we wanted to contact. And some had simply expired. And yeah, this was an issue because most of the microgateways were actually configured to ignore those issues and just route traffic anyway. And with the Kong default config, that was not the case. So instead of weakening our security, we actually made a hard decision to tell our customers to, well, fix your certificates. And once you've got them set up correctly, traffic will work. In the meantime, we could route them back via the microgateways, but basically there was a cut-off date. Second of all, Kong behaves slightly different from the microgateways. I mean, ideally and in theory, we're just proxying traffic. But of course, the gateway always adds some headers, and maybe the backend doesn't like that. And also, when the backend sends some headers in the response, Kong might behave differently from the microgateways. So we ran into issues where a backend was actually sending the same header twice with different values, and Kong would basically strip one of them. And the microgateway did the same, but it actually stripped the other one. And so, yeah. That's kind of an issue for some of the consumers that were relying on the header information there. Also, config maps have a size limit. So in the first setup, we set up Kong without a database. We just had a standalone setup with a static configuration that we basically just updated by setting up a new Kong instance all the time when we had to make changes. And well, in Kubernetes, a config map can get up to a size of 1 megabyte. Which should be fine for quite a few routes and services. But in Kubernetes, if you apply an update on a config map, it also stores the history in its annotation. So the config map kind of grew, and suddenly we couldn't update Kong anymore. It was kind of bad, and it basically also gave us a good idea that, yeah, we will definitely run with a DB when we are moving to the Gorilla service. And lastly, well, some customers, they just don't test. You can tell them as many times as you want to that, yeah, now is the time they should test whether their routes are still working. Some just don't. And they will complain later, basically, weeks after the migration is completed. So this is kind of an issue that we ran into, not getting responses from some of our consumers. Now, step 2, we set up the Gorilla service. And this was actually already in the new data center. So we had the Kong pilot still running in the old data center, using the existing domain names and everything. And we set up the new Kong instance with a DB, in this case, we used Postgres. And we pointed some new domain names at it, and we had that set up in parallel. Now, in order for this to work for testing, we imported our configuration using Back. So basically, we took the static configuration we had, ported it over to the Gorilla service, and yeah, so now basically everybody could start testing their routes via the new Gorilla service just by changing the domain names, right? So yeah, in theory, I mean, we had the same Kong, but it's a different data center, and some of our targets did not have firewalls open for our new Kong instances to access them. We were aware of that, of course, in advance. So we knew that some might run into issues because they only permitted traffic from that one data center earlier. And we did some batch checks and we did some scans to basically see who might run into issues. But again, that takes a little while, and also there's customers who are just not testing. And also another issue we ran into, with the new domains, we set up a new certificate process. So basically our certificates were auto-generated using Let's Encrypt. And we also had a more strict cipher settings where we said, okay, we want to be as secure as possible. But some of the clients that basically access the APIs, they come with old Windows server boxes, which maybe don't have the most current ciphers installed. So yeah, they ran into issues there. Luckily, a lot of them basically actually did test, and we could catch them in this phase already and work with them to, yeah, basically get their systems updated. Now, the big day, step 3, we had the big bang. So the idea behind that is very simple. We just pointed the old domain names to the new data center IPs. So we just did a DNS switch over, and all the traffic was running via Gorilla service. Now, of course, we also ran into issues here. There's clients who actually ignore DNS timeouts. So we reduced the DNS timeout for our domain names, for the old ones, before moving them over. But some clients, they just ignore it altogether. Basically, even days after the migration took place, we still had traffic running via the old Kong pilot, because some of the API consumers just didn't care about changing IP addresses behind the DNS. Like, it was probably a client just requesting it once in the beginning, and then they just point everything to that IP. So yeah, this took quite a while to basically get to know who is behind that caller and who do we contact to tell them they should restart their client application. The second thing was that basically the DNS switching was done via a ticket that we had to send to a different team. So we didn't have an easy fallback. Luckily, everything went fine, and we just migrated the development gateways first, and then integration, and then production. But yeah, this was kind of a tough situation to be in, because if we would have had an issue, we wouldn't have had an easy fallback there. Again, of course, some clients just don't test. And the migration, we did it without downtime. I mean, with the DNS switch, traffic could flow via either side and it worked fine. We even had some customers who didn't read their emails and they didn't even notice the move. So like weeks after, we got config files that they sent us for the microgateways where they wanted to have a change. And we were like, no, we just migrated some weeks ago, you know, like we announced many, many times and you should have tested. But yeah, it worked so fine and so smooth that they didn't even notice that. All right, so yeah, that was basically our migration that we did. And in summary, we have that wonderful central API management stack, which is designed for self-service and simplicity. And using our open gateway infrastructure, we've got all the options for basically everybody hosting their own gateways. And yeah, we've got a great API provider community.
So to recap, our large migration was possible due to careful planning and thorough execution. The main focus of the Gorilla service is to enable our business partners to focus on their core business. It has been designed for self-service and simplicity and guides as an example for other teams that might adopt similar solutions in other regions.